Welcome to the last lesson in the Transformations unit. Lesson 3.5 discusses symmetry, specifically three types. Point symmetry is a figure with 180-degree rotational symmetry. Reflectional symmetry is a figure that maps onto itself when it is reflected over a line. And rotational symmetry is a figure that maps onto itself when rotated about the center by an angle less than 360 degrees. To identify symmetry, try to identify the line or lines of symmetry, then determine what type of symmetry results from that line. If we look at this first one, we have two lines of symmetry, one that goes through here and one that goes through here. This one has reflectional symmetry because it maps onto itself over the horizontal line of symmetry and also over the vertical line of symmetry. And then it also has 180-degree rotational symmetry because when you spin it around, it's going to end up the same orientation as what it started with. So that means that if it has 180-degree rotational symmetry, then it also has point symmetry. Okay, let's take a look at this one. This one has a line of symmetry that goes down through the vertical middle and also the horizontal middle. So this one has the same symmetry as the one next to it, so we can rotate it 180 degrees and we're going to have the same orientation, which means that it also has point symmetry, and we can reflect it over this horizontal line or over the vertical line and it'll map onto itself. Okay, last figure. This is a funny little figure. An actual circle has an infinite number of lines of symmetry. However, this one, assuming that this is down the middle, we'll assume that it is. This one doesn't even have rotational symmetry of 180 degrees because 180-degree rotation puts the mouth up here on the forehead and the eyes down here where the mouth is. So the only kind of symmetry that it has is reflectional symmetry. Lines of symmetry will be located in two places. One, lines of symmetry will go through the vertices, and lines of symmetry will go through the sides. Okay, let's just rewrite that. There we go. Through the vertices and through the sides. So from this one right here, we have 1, 2, 3, and then also through the vertices, 4, 5, and 6 lines of symmetry. So we can go through the sides and through the vertices, and that's going to work when you have an even number of sides. When you have an odd number of sides, like a pentagon, then those you may be having lines of reflection that go through a vertex and then through a side. This one right here has 2 lines of symmetry, one through there and one through here. It looks like we should have one that goes through here, but as it turns out, if you flip this over, you're not going to have the same orientation, so that's not going to work. And then finally the last one, we have a line of symmetry that goes through the vertical center, but not through the horizontal center. Okay, let's identify rotational symmetry. We're going to take a look at some shapes before we do this. In order to have rotational symmetry, when you spin it, it needs to end up being the same orientation. So for example, if we take a look at this rectangle, okay, if I turn it 90 degrees, I still have a rectangle, but now I have a short rectangle instead of a tall rectangle. That's not the same orientation, so it does not have 90-degree symmetry. Now if I turn it another 90 degrees, which is 180 degrees, now it looks like it did in the beginning. So now we have 180 degree rotational symmetry. We also have point symmetry because it's 180 degree rotational symmetry. Okay, let's look at another one. Here's an equilateral triangle. Each side is the same. So I have lines of symmetry that go through here. So one vertex through one side, through another vertex and another side, and finally through the last vertex and the last side. And the way this turns out is that I can turn this on each side, and I'm going to have the same orientation. Okay, so that's a total of 3 rotations within one 360 degree circle. And so if I divide that 360 degrees by 3, I end up with 120 degrees. So this one has 120 degree rotational symmetry. Okay, last one. Let's take a look at this one. This one's a square. Okay, I can turn this 90 degrees and I still have a square. And I turn this another 90 and I still have a square. That's 180 degrees, so that's also point symmetry. Another 90, which is 270 degrees, and I still have a square. So 90, 180, and 270 degree rotational symmetry. Now, what if I only went halfway? So instead of 90, I go 45 degrees. Okay, now I don't have a square. I still have a square, but the orientation is more like a diamond or a kite. So since I don't have, or not a kite, but a diamond. So since the orientation is different, then I don't have rotational symmetry at 45 degrees. Okay, let's take a look at what we have down here. So this one, equilateral triangle, and I'm going to go ahead and mark the sides. So we took a look at that one already. We turn it to this base, and then we turn it again. So we would have 360 divided by 3 is equal to 120 degree rotational symmetry. We would also have any of its multiples, so 120 degrees and 240 degrees rotational symmetry. This one right here, I have a line of reflection, but it doesn't actually reflect over. This is the one kind of like what we had over here when we tried to rotate it or reflect it over the diagonal. It's not going to work. It does, however, work. If you notice, this is leaning towards the right. Okay, if we flip this over, it is still leaning towards the right. So we do have 180 degree rotational symmetry, which means we also have point symmetry. Okay, and then looking at this last one, if I turn this 90 degrees, same figure. Okay, that's going to happen all 4 times. So this one's going to have 90 degrees, 180 degrees, and 270 degree rotational symmetry. And then because it has 180, it also has point symmetry. Okay, go ahead and flip this over. So, determining symmetries can start with finding the lines, but it doesn't have to. Okay, so if we look at the symmetries that we have right here, we have 1, 2, 3, 4, 5 lines of symmetry. Now don't make the mistake of counting all of the ends, because then you're going to count 10 and you really only have 5 lines. So you'll be doubling the number of lines that you have. Each one of these can be mapped from, like line 1, this petal right here can be turned to map onto line 3, which can map onto line 5, and we can do this all the way around. So we have 5 different ways of mapping this in one flower. So if we take 360 divided by 5, we're going to get 72 degrees. So that means we have 72 degree rotational symmetry. In the second figure right here, we have no lines of reflection. Ordinarily, we could draw one down here, but when you flip this over, this dot is going to be right here. This dot is going to be right here. It's not going to have the same orientation. So, with this one, although it has no lines of reflection, it does have 180-degree rotational symmetry. So notice that the dot is in the upper right-hand corner. If we go 180 degrees, still going to be in the upper right-hand corner. So this one does have 180-degree rotational symmetry, which means that it also has point symmetry. And finally, we have this square. All the sides are the same, all the angles are the same. So we have a line there, we have a line here, we have a line that goes through the diagonal, or through the vertices, and we have another one that goes through the vertices, and we'll call that diagonals. So we have 4 lines of symmetry, or 4 lines of reflection. We have 90-degree, let's see, we'll go ahead and write this down. So we have 4 lines of reflection. We have 90-degree symmetry, rotational. And we have, since we have 90, that means we also have 180 and 270 degrees, so we also have point symmetry. And I'll go ahead and number these so that we are consistent. Okay, now that's about all there is to lines of reflection and determining symmetries. So let's take a look at what we have down here. Down here, you are going to be figuring out the number of lines of symmetry for each figure. Go ahead and see if you can put those on there. We're going to take a look at these in class, and you should have them finished for that. Right here, describe the rotational symmetry of each figure. State whether each has point symmetry. So if it has 180-degree rotational symmetry, then it will also have point symmetry. Finally, identify the types of symmetry of each figure. For each figure with reflectional symmetry, identify the lines of symmetry. For each figure with rotational symmetry, identify the angles of rotation that map the figure onto itself. Go ahead and fill these out on your paper, and we will take a look at them in class. See you later.